Good day to you out there. I am welcoming you to Science Explained. Today, I want to pick it up from where I stopped on trigonometry. Like I promised, that I am going to treat the topic from the root to the top. So this is going to be another episode. If you have been following me, the last episode stopped at proof of trigonometric identities, where I was able to prove two identities which are already on the board, 1 and 2. If you are not aware of this, please go and click on my channel and you pick on the trigonometry. You will see this is the last episode where it stopped. Now, I want to prove another identity, which is the third one. Please come along with me. But before I continue, I would like to pause the video for you to try and give me any identity that can be proven through any of these two already existing identities. All right. Now, I want to prove another identity from the already existing two identities seen on the board. From identity 2. From identity 2, that is the second identity, which says sine square of theta plus cosine square of theta equals to 1. I am quoting this. I want to achieve something from here. And what is that? I want to achieve tan. Don't forget that tangent theta is the ratio of sine theta to cosine theta. That means if I want to set up sine over cosine from here, what do I need to do? All I need to do is to divide through by cosine square theta, because cosine theta is the denominator, while sine theta is the numerator in the identity for tan theta. Meaning that for me to achieve tan here, I need to divide throughout by cosine square theta. So dividing through by cosine square theta, I will have sine square theta over cosine sine square theta over cosine square theta plus cosine square theta over cosine square theta equals to 1 over cosine square theta. I have divided through by cosine square theta. So what happens next? It is obvious that this will cancel this. Now, I have sine square theta over cosine square theta, which is the same thing as sine theta over cosine theta all squared, plus this gives us 1 equals 1 over cosine theta all squared. Now, sine theta over cosine theta, according to identity 1, is what? Tan theta. That means the whole of this becomes tan theta raised to power 2. That will now be tan square theta. Tan square theta plus 1 equals to, according to the 6 trigonometric ratios I gave during the first episode on this topic, I made it known then that 1 over cosine theta is the same thing as secant theta. That means this will be secant theta square. That is secant square theta. This will be the third identity. Do not forget that by flipping one of these trig ratio to the other side, you can get another identity through here. For example, if I transfer 1 to the other side here, that means tan square theta will be sec square theta minus 1. And so on and so forth. And if I transfer tan square theta to the other side, that means sec square theta minus tan square theta will be what? 1. So let's take note of that. Now, I want to prove the fourth identity coming from second identity. You can see that the second identity is like a base to generate other identities. Okay, this time around, instead of dividing through by cosine square theta I did the other time to get this one, let me divide through by sine square theta. Dividing through by sine square theta. Alright, that means that will now be sine square theta divided by sine square theta plus cosine square theta divided by sine square theta equals to 1 over sine square theta. I have divided through all through by sine square theta. That is in equation 2. I divided all through by sine square theta. So what do I have? It's obvious that this will cancel out this to give us 1. That means I'm going to have 1 plus open bracket cos square theta over cosine square theta over sine square theta will be cos theta over sine theta all squared, because the square affects both of them now, equals to 1 over sine theta all squared. Alright, going back to my first episode, out of the 6 basic trigonometric ratios I gave, one of them says that reciprocal of sine theta is cosec theta. That means 1 over sine theta will be replaced with cosec theta. So I will have 1 plus y cosine theta over sine theta will be cotan theta. All of this information you will find in episode 1. That means this will be cotan square theta, because cosine over sine is the reciprocal of tan, and reciprocal of tan is cotangent. That is why we have cotan square theta, because of this square, equals to cosecant square theta. That is the fourth identity.